The slides will probably be shared later on. I think there was some miscommunication. Either way, hi everyone. Welcome to. Why does it say week 12 here? Oh god, it's 1.2. Okay. Hi everyone. Welcome to week 1.2. This is where we start the coding bits. Finally got a link to the slides as well. Let me. You'll find it in Discord somewhere. You don't need it for now. You can just follow along and then look at slides later on. Today's class is very foundational. So if you were in the first cohort, if you know JavaScript well, it will be slightly easy for you. These are the topics. Feel free to pick and choose. In case you want to leave initially, it's fine. Come back later if you know these are the things you want to cover. If not, if you want to go 0 to 1, this will be very basic, very slow. We will go. We will try to understand as much JavaScript as we can today. The goal is, as I said, by the end of it, whoopsie daisy. Yeah, there we go. Sorry, operational hazard. By the end of today's class, you're done with the JavaScript jargons, JavaScript interview questions, enough JavaScript to kick things off from next week onwards. More specifically, if you look at the concepts here, it is going to be daisy. Hello, mic testing. Can you guys still hear me? Yes or no? Sorry, guys. All right, good to go. Yeah, so as I was saying, we'll understand very foundationally why you need languages in the first place, which is basically very beginner friendly. If you've never coded before, this section is for you. Interpreted versus compiled languages. Why JavaScript is better than other languages for some use cases. Strict versus dynamic languages, like strictly typed languages versus dynamically typed languages more specifically. Single-threaded nature of JavaScript. Some primitives in JavaScript, numbers, strings, booleans, things like these. Basically, here is when we start to code a little bit. Before that, it's very abstract, high level. Complex primitives in JavaScript, arrays and objects. Functions in JavaScript. Some practice problems. Something called callback functions. Yes, this part, last two things are. The advanced bit, we'll probably take a break around here. And these two things, as much as we can cover, we will try to. Rest, we will either do next week or create an offline video. I can tell you from the high level, okay, everything abstract should be super easy. If you have never coded, these two sections might be slightly advanced. And then finally, from here onwards, from here onwards is very advanced as in, if you've never heard of these things before, they will be jarring. It is fine, supposed to be jarring. We'll take some iterations to get there, okay? But let's start slow. And let's kick things off with why languages, okay? Again, if you've not coded before, should be straightforward. And don't like drop off today. Try to stick as much. And if today's class feels overwhelming or whatever, we'll do another extra class in the coming week. Okay? First class needs to be very foundational. So yeah, that's all the prerequisites. Let's get right into it. Let's understand why languages. Why do you need a language like C, C++, Java in the first place? Why were they introduced and why are there so many languages? Why can't one language do everything that's needed that a programming language does? The answer is, before discussing languages, discuss a little bit how our computers work. Some of you might already know this. Okay, computer has something called the RAM, the SSD. Whenever you're trying to buy a new computer, you do this. You sort of ask the specifications, which sort of the thing to keep in mind there is what is the RAM, what is the SSD, and today these days it's what does the graphic card look like for crypto mining or machine learning algorithms. But that's the high level of what you look for. The question is, what is this RAM and what is this SSD at the high level? And the answer is, whenever you have an application locally that includes my Zoom application, that includes VLC player, WhatsApp, Telegram, any application that you're running on your machine resides in this thing called the SSD, which means the hard drive of your machine, which usually is 500 GB, 1 TB. Your photos, your videos, your movies that you have, everything resides here. But when you run something, what does running mean? The Zoom call that is happening right now, if I actually start a movie on my machine, my browser that is currently running, when you're running something, it runs in something called the RAM. What does this stand for? It stands for random access memory. Basically means the current things that you have running on your machine reside here. Everything else that's not currently running, photos, videos, reside here. If you have games, other offline things, they all reside here. Currently, the thing that's running is residing inside the RAM. This is any application that you have. VLC, Zoom, WhatsApp, everything resides inside the RAM. But if you double click, so it's statically present on the machine, but if you double click on VLC, if you open it, is when it goes into RAM. But the question is, what exactly goes into RAM? What does going into RAM even mean? And the answer is, okay, what exactly is the RAM? What exactly is SSD? It's some hardware, right? If you look at my Mac machine that's right here, it has some wires, some circuits, things like these. And they understand, your machine at the very lowest level only understands what's called zeros and ones. Basically, any final program that you run on your machine, be it a game that looks very fancy or a Chrome browser, in the end, what's running in this RAM thingy is a bunch of numbers. Why, Harkirat? Why are there a bunch of numbers running? The answer is, okay, your RAM, this hardware that's present, doesn't really understand programming languages. It only has like some sort of circuits which can either be on or off. And since there can only be two states, they are usually represented by zeros and ones. Why am I saying so much 0 to 1s here? Because whenever you're running any program, what is finally going into the RAM is zeros and ones. Okay? Feel like I'm going a little fast here. Let me take a breather here. How is chat doing? Let's take a small pause here. Sorry. Been 2 weeks since I've taken a class. All good? All good? All right? Cool? All right. Thank you. Been a while since I've taken a class. So, I think I'm going a little haywire. Chalo, theek hai. Let's get back on track here. Whenever you execute anything on your machine, it goes into RAM. What goes into RAM are zeros and ones, not any source code, not any C++ program. Okay? Does that mean VLC, the developers of VLC wrote zeros and ones when they were writing the code of VLC? No, they probably wrote it in either Java, JavaScript, C++, some language. And thankfully, VLC is open source. So you can actually go there and see that VLC is actually written in C. You can actually read through the source code of VLC. But I just said that whenever you double click on VLC, what goes into RAM is zeros and ones. So how does this code get converted to zeros and ones, which is what goes into the RAM? And the answer is using something called compilers. C, C++, Java, JavaScript are all high-level languages in which you write code like this that you see here on the screen. And all of them have what are called compilers, which convert this high-level code into zeros and ones, which actually go into your RAM and your machine can understand. Okay? That is why you need languages. You need languages because developers are very dumb and they can't write, code like this. It will be very hard for you to code in zeros and ones. It's much easier to write for loops, if else, high-level logic statements. And thankfully, there is a compiler that under the hood can convert your logic statements into zeros and ones. That's the high-level need of a language or programming language. But why are there so many? Because, people have various optimizations and some use cases can only be built in certain languages. For example, browser code or websites can only be written in HTML, CSS, and JavaScript. Some other programs, like most other programs, can actually be written in any language, but there are some advantages to some languages, which is why, everyone creates their own and they have competition amongst each other. In the end, every programming language is just converting high-level code into zeros and ones. Okay? All right. Any application that you have on your machine is going to be written in any of these languages that you've heard of. And all of these languages have a compiler which convert these into zeros and ones, which is what goes into the RAM. Okay? That is how any program is written in any of these languages and actually compiled and put inside the RAM. Languages are used to write applications. What is an application? All of these, even a GTA game, some other game you might be playing these days, Fortnite, are all written in one of these languages. Developers write the high-level code in these languages, and every language has a compiler which converts the developer's code, which is in this language, into zeros and ones. Okay? That is the basics of why you need high-level programming languages, because developers can't write code like this. Cool. Let's get into the compiler, this thing that I was talking about that converts high-level code into zeros and ones. What are compilers? Compilers convert high-level developer-friendly code into zeros and ones. What do I mean when I say developer-friendly code? I mean things that you can write in plain English, right? If you've looked at any code until now, any DSA problem you have solved, you write simple logic in if, else, variable names, things like these. Compilers do the heavy lifting of converting that into zeros and ones. Let's see this in action. Let's look at a very small code base in C++. If you don't understand it, it's fine. C++ is not part of this cohort, not meant to understand this syntax. But at a high level, try to read through the code that's written on the left. There's a bunch of fluff on the top and the bottom. Ignore everything. Just focus on this one line which says cout hello world and L. This is a file that a developer has written, similar to how developers at VLC have written very big files to create that program. Some developers, me only a few hours ago, wrote this program. And what is it supposed to do? It is supposed to print hello world on the screen. What does that mean, Harkirat? What happens when you double click on VLC? It plays a song. What happens when you double click on the GTA folder that you have in your Windows machine? It starts a game. Similarly, whoever will start this program, they will just see hello world written on their screen somewhere, and then the program will die. That's all this program does. It's a very simple C++ program. Let's see how you actually run this locally on a Mac machine. You don't have to do it right now. I will do it just on my machine very quickly. You don't have to do it. So don't worry about writing this code locally and actually running it. Okay? This thing, there's this C++ has many compilers. The most famous one is G++, which lets you compile your high-level C++ file into the zeros and ones that I was talking about, which is usually called a binary because it only has zeros and ones. This is the command that you can run to convert your CPP code into a binary. Once you run this command, this file will get converted into zeros and ones. And then you can just run that zeros and one file, which is, in my case, I called it temp. So this temp file that is created is similar to the GTA file that you have on your machine. You double click on it and it prints hello world on the screen. Let's see this in action really quickly. Locally on my machine, you don't have to worry about writing any of this. Step 1, writing some code in C++. I have already written it. I'm opening it here in my terminal. If you don't understand what this terminal is, don't worry about it. Just think of it as this is my file system. I have a bunch of files here. I have a.cpp file here as well. I want to convert this into this temp file. I already did this before the class, which is why, this and the binary both exist. But let me delete this binary file that I have here. I only have a single CPP file. If I open this in VS Code, you will see it is the same code that I showed a while back. Again, don't worry about any of this syntax. Just focus on this one line. And what this line does is it prints hello world on the screen. I have this high level code that I have written. Let me compile it. Again, don't worry about how it is getting compiled and what is this command here, what are commands in general. We will figure it out. Something I ran on my machine that created this temp file. The command seemed to have run correctly, which is why if I now open the folder again, the temp that I had deleted came back. This is the GTA file that you see on your Windows machine when you install that game. If I double click on it, you will see, ignoring all the fluff, you see hello world written on the screen. Your program is working correctly. Your compiler, G++, is able to convert a high level CPP file into a binary that now you can send to your friends. That way your friends cannot see your source code. They actually can sort of reverse engineer your source code. What do I mean by source code? All the code that you've written here. But you don't necessarily have to share this with your friend. You can only share the final temp file with your friend, which is basically this file. If you share it with your friend, they can run your code. Right now your code is simple. You can write more complex logic here to, create a game, things like these. That's the basics of a compiler. All right. This is how C++ compiles and runs. As you can see, there are 3 steps. Step 1, compiling the code, creating a new file. Step 1, writing the code. Step 2, compiling the code. Oh, oopsie daisy, where did it go? There you go. Step 2, compiling the code. Step 3, running the code. There are 3 steps. But JavaScript is different. That is what we're talking about in these slides, which is interpreted versus compiled languages. C++ is a compiled language. What does that mean? It means it first converts your high level code into a binary. Then you can run the binary, distributed, whatever. But there is one pre-existing step that converts this into a binary. JavaScript is not like that. JavaScript is a interpreted language. What does that mean? That means You write your JavaScript code, which in my case I've written the same code in JavaScript, which is a single line of code. As you can see, it's much leaner to write code in JavaScript versus C++. C++ had 10 lines. This has just one line. And when I run this code, I can simply directly run this code. I run the node a.js command on my machine. I see hello world printed on the screen. Notice I don't do a specific compilation step. I never convert my JavaScript file into a binary first and then run that binary. I simply run the node command on this file to run this specific code. You might ask, Arkiat, does that mean that this code is, going as such into the RAM? The answer is no. It is still converting this code into zeros and ones, but it is going line by line. It is not worried about, a high level compilation step of converting this file into this. It is going line by line. If there were 10 lines here in C++, first the whole thing would convert to temp. Then you would run temp and it would run all those lines one by one. But in JavaScript, if you had 10 lines here, it would not be like, chalo, I will first compile the whole thing. No, seriously. It will not first compile the whole thing and then run the whole thing. It will first run the first line, then run, like you can think of it as it will first convert this first line into zeros and ones, run it. Then it will convert the second line into zeros and ones, run it, so on and so forth. This is what's called an interpreted language. What is the benefit of one over the other? Let's read through it. Compiled languages first need to compile, create the temp file, then need to run. Usually don't compile if there is an error in the code. This is one special thing about compiled languages. They usually don't compile if there is an error in your code, which means if you had an error in your C++ code, you will never be able to create the temp file. This is in stark contrast with interpreted languages, which usually go line by line, can run partially if the error comes later, which basically means if you have 5 lines of code and there is an error on your third line of code, then line 1 will run, line 2 will run, and line 3 is where you will see the error. So it will partially be able to run the program. That is why it's called interpreted and running line by line, versus C++, you will never see partial outcomes. It will first compile. Compilation is what? It's just converting code from one thing to another, right? Running is where, the thing actually runs. This will either run fully or not run at all. This can run partially. Let's write some code now so that you guys warm up, I warm up as well, and we are not following a class in a very teachy fashion. So let's try to see this in action. At this point, I would urge you to go to Replit, which is an online programming thingy where you can, run C++ files, JavaScript files without installing G++, for example, on your machine, or without installing Node.js on your machine. So just go to repl.it, which is this sort of website, and try to sign up there. I'll give you guys a minute. I've been using ChatGPT to create examples. I will wait for a minute, also do a quick poll. Until then, please sign up on repl.it and reach this page. Thirty more seconds. All right. Once you're here, click on create REPL on the top left and create a Node.js REPL. What this means is it is going to create a playground thingy where you can write some basic code in Node.js or JavaScript more specifically, which is what we are going to do. We are going to write some code, try to compile it and run it, and try to see the output of that code. Seems to be taking a long time, which totally could be because so many people have opened Node.js REPLs at the same time. wow. Are you guys also not able to boot up a Replit? We might have just broken it, if I'm being honest. Let's see. Are you guys able to boot it? Yes or no? No? Yeah, we've probably broken Replit. All right. Cool. In that case, we can do one of two things. First thing we will do is we will bring this in-house as well. Let's bring a compiler in-house and create a bigger bounty for it. It's a hard problem to create a platform like this, but we should create one. More specifically, I'm going to ask another question here, which is, do you guys already have Node.js on your machine locally? And if yes, then please don't open Replit. But do you have Node.js installed on your machine? Yes or no? Oh, seems like most of you guys do. So in that case, so 90%, please go to your machine. 10%, the people who don't have Node.js on their machine, just go to Replit, and I hope it just works for you guys, but it seems like it won't. So feel free to follow along, but code later on. You won't be able to code right now for the sake of moving forward. I'm going to proceed, and everyone who does have Node.js locally, open Visual Studio Code and create a fresh project over there. The way to do that is you can go here, file, go to your file system and open a folder like this in your file system. I'm going to open this cohort 2 folder. I'm going to create another folder here called class 1. Feel free to create a folder on your machine just like you would generally, and create an empty file here. Now I don't know if there's an easy way to do this in this GUI. Seems like there isn't. So what I'm going to do now is go to Visual Studio Code, file, open, and open this specific folder, class 1, in Visual Studio Code. Hopefully that is not too difficult. I'm going to wait for 15 seconds for you to do it. What have I done? Created an empty folder on my machine, and then file, opened that folder on my machine. That's all I've done. 10 more seconds before we proceed. All right. Now create an empty file here, call it whatever, main.js, a.js, whatever you want to call it, should be fine. And write some code with me. This is very basic code that we just saw. Once you have this code, try to run it locally. If you have Node.js locally, hopefully you already know how to run Node code locally. One thing you can do is go to terminal, new terminal, close this section here, and run the command node main.js. Once you do, you should see hello world printed here on the screen. Going to wait for 15 seconds for you guys to catch up and create all of this. For people who don't have Node locally, try Replit now. Since everyone has left, there is a good chance that it starts to work. Maybe it doesn't though. Yep. Never mind. Replit is down. So feel free to follow along, and when Replit is back up, I can show you how you can do the same thing on Replit. That way you don't need Node installed locally on your machine, but generally would urge you before the next class, try to get Node installed on your machine. All right. Let's make a small change in this code base. Let's add console.log a here, where a is a variable. If you don't understand this, it will come in a few slides later on, how you write code in JavaScript. But basically at a high level, this line is incorrect. It is wrong syntax. You cannot write this. Your program should not run if you write something like this. If I now run node main.js, you will see it prints hello world, but then it gives me an error. What does that mean? It is able to partially run the program. The same thing if you do in C++, you will never be able to see this partial outcome. During the compilation itself, it will fail. That is the only sort of reason we did this exercise, to show that this code will partially run in JavaScript because it is an interpreted language, will not run even partially in C++, which I would urge you to try out later after the class if you want to. To create a C++ file, I'll show what that file looks like, and then try to compile it, and you will see that the compilation does not work. Okay? Again, just to show the code, this is what the code looks like. Very simple, very straightforward. If you don't have Node right now, it is fine. If you're not able to run this for some reason, it is fine. Feel free to come back to the video and try this. There's nothing new to learn here. It's just to show you can partially run programs in an interpreted language. Cool. Let's move on. This is the code that we just ran. You saw there was a partial output. This is the same variant in C++. And if you write this code and try to compile your code, it will give you an error during compilation itself, which means the temp file is never created, which means you can never run the program even partially. Cool. What did we learn? JavaScript is an interpreted language. C++ is a compiled language. Interpreted languages go line by line while executed, can partially run when an error comes. Compiled languages cannot. Cool. Second section done. We understand hopefully scripted versus not scripted exactly, interpreted versus compiled language. There's actually a typo here. All right. Why JS is better than other languages? This is slightly controversial, but long story short is the reason JavaScript is so popular is your browsers can only understand HTML, CSS, and JavaScript. This is not technically true. There are ways to make C++, Java, any language run in a browser. But for most websites, 99.9% of the websites, JavaScript is the primary language. You definitely need JavaScript. You can still run C++ somehow, but JavaScript is definitely needed. This is the standard that was created a few years ago. Okay, these three languages, browsers will interpret and browsers will, render websites a certain way based on these three languages. Everyone has created browsers, Chrome, Edge, Brave, and they now interpret this. If we ever want to change this, JavaScript is not going to be the primary language. We have to, all the existing websites will go away. 2, create new browsers that understand these new languages. If someone wants to create a browser that understands Rust, or create a new standard, any website needs to be created from now on needs to be written in Rust. There's a lot of things that will need to happen, so that will basically never happen. HTML, CSS, JavaScript is the standard that will almost always remain the standard till eternity to create websites. That is the biggest reason why JavaScript is popular. Thanks to Node.js, JavaScript can also be used for backend development. This is the reason it's better than other languages. Not really better. Other languages are better when it comes to speed, concurrency, a bunch of other things. But JavaScript is needed, sort of. Why? Because websites cannot run without JavaScript, so you have to have JavaScript in your stack. Strict versus dynamic languages. So one other difference between C++, Rust, Java versus JavaScript, Python, you will notice is they have what are called very strict types, which basically means whenever you're writing some code, as you can see the code on the left, it says int number equal to 5, which means don't worry about the syntax, don't worry about C++, or general JavaScript syntax. It will come in the slides to come. But if you can understand this, you first define this is an integer, int stands for integer, and then you try to assign a string to that integer. When you do this, C++ will fail. This will cause a compile time error. What is a compile time error? When you run the G++ command, C++ compiler will tell you, you are trying to change the type of number. This is an erroneous program, it won't run. But in JavaScript, the same thing will run. Why? Because JavaScript is what's called loosely typed or dynamically typed. I don't know if dynamically typed is the right term, but loosely typed is most probably the right term, one of these two, which basically means it allows you to change types of variables. This is not great because as your project grows, you will see a bunch of what are called runtime errors, because you're changing things throughout, and almost certainly you would never need a number variable, a variable that's called number, to be assigned to a string. So there is definitely some error here. This is why C++ is catching it up front and telling you you're trying to change the type. So this is good. It is more strict code, which is super useful in a big code base. In JavaScript, you can move fast because, there are no compilation errors. You can just, keep going through and have an erroneous program of sorts that gives you a runtime error. That is okay. But usually in big projects, it's good to have types, which is why TypeScript came into the picture and, makes JavaScript more static, which means it adds basically the same things that you see here. You can add in JavaScript by using TypeScript, but we will get there when we get there. That is a optimization on top of JavaScript, or sort of a new language. JavaScript, the raw JavaScript that was written to be dynamically typed, which basically means was written in a way that you can do a lot of things that standard old programming languages won't let you do. One of those things being, changing these types in the middle of the program. Cool. That's strict versus dynamic languages. Lastly, single-threaded nature of JavaScript. This is the last slide before we start some real coding and understanding JavaScript syntax. There are like two popular sort of paradigms when it comes to programming languages: single-threaded languages and multi-threaded languages. What are single-threaded languages? JavaScript is the most famous one, notorious for being single-threaded. What are multi-threaded languages? Java is one, C++, Rust. They're all multi-threaded. But what does this mean? What does even threaded mean? What does single-threaded mean? The answer is, okay, whenever you buy a new machine, you always look at the specs, and one of the specs you look at is the number of cores. For example, this is my Mac screenshot, and here you can see I have 10 cores. What are these cores? It basically means one single core can run certain code at the same time, at like a single time, which basically means if I have a JavaScript file that I'm running, that JavaScript file is running on one sort of core. And if I start another JavaScript file that can run on another core, a single core can't run two things at the same time, which is why you sort of optimize whenever you're buying to get more cores. The more the number of cores you have, the more the number of processes you can start. For example, on my Mac machine, I'm currently running Zoom, I'm running a browser, I'm running a recorder that's recording the screen, I'm running these slides. All of these are processes that are running on one of these cores. You might ask, Harkirat, do you only have 10 processes? If you only have a 10 core machine, you should be able to run only 10 processes at a time. The answer is there's something called context switching, which basically means not every process running on my machine needs the CPU at all times, which is why this single CPU might be running Zoom as well, might be running this slides as well, might be running something else as well, because it can context switch between processes. Ki haan, abhi I'm running this process, abhi I'm running this process, so on and so forth. So that is what is a core in a machine. It is one place that can run some code at a single time. It cannot run two things at the same time, which means if I run two Node.js processes on my machine at the same time, the single one won't be able to execute them both together. It might context switch between them, which means it might run this one a little bit, then run this one a little bit, then run this one a little bit. It cannot run them parallelly. For that, one might be running on one core, other might be running on another core. Single-threaded nature of JavaScript means that this language, JavaScript, is always restricted to a single core. You can always, if you have 10 lines of code, they will always run one after the other, one after the other, one after the other. You can never split your program of sorts into like two different cores so that you can, decrease the time that it takes for a program to run by half. Other languages let you do it, Java, Golang. These languages let you split your sort of load across cores somehow. And that way, your process becomes more optimal. JavaScript is single-threaded, which means it has a single thread, which means it will only use one core of your machine at a time. This is something related to this is the bounty for today, which will come later. But hopefully that's at a high level clear. Single-threaded nature of JavaScript means that JavaScript can only use one of these at a single time. It is single-threaded. This is why it is considered to be a bad language for scalable systems. Because if you have a 20-core machine on AWS that you've rented for $500 and you're running a Node.js process there, it is just using one core. It is the same. It will give you the same performance as if you were renting a small one-core machine. So it might make sense for you to just rent a one-core machine than, renting a 20-core machine on AWS, because you're not really using the benefits of those 20 cores. If you're running multiple processes there, then fine. But if you're only running a single process there, then all of these will be on 0% capacity. This one will be on 100% or whatever, some capacity. There's no point paying for these many cores if you're running a JavaScript program there. If you're running a Java program there that is using multi-threading correctly, then it's fine. But JavaScript, you won't be able to squeeze out any extra value by using a bigger machine. There is a way to make it use all the cores on your machine. We will come to that later on. You can sort of parallelize JavaScript somehow using something called the cluster module if you want to Google it later in the class, but we will come to it later. For now, it's a single-threaded language, which means it can only use a single core of your machine at a time. More practically, JavaScript runs line by line. Only one line runs at a time, which means if this is your code base, first this line will run, then this line will run. You might ask, Harkirat, does that mean C++ mein two lines can run at the same time? Do you mean this line can run on one core, this line can run on another core? The answer is no. If you have written code like this, Even in C++, it is running one after one after one. It is sequential code. But C++ lets you create new threads here using some syntax. Same for Golang, same for Java. Golang lets you create what are called subroutines, which basically where you sort of fork your process. You do this thing, you do this thing, you can split your program across this thing. This code that you see will still run on a single machine, single core. You can write code here though that lets you split your program into two cores or like two threads, and that way you can use the power of multiple cores on your machine. If you ever want to do a little bit of Golang process like coding after the class, try to go through what are called subroutines that basically solve this specific problem only. Okay. Let's see. So this code, if you write more code, it's just running line by line by line. It is only using a single core of your machine. Never can you split your load across two cores. In JavaScript, there are ways to do it, but usually, currently, for all the things that we're discussing in this class and for a while, only one core of your machine you can use. Okay. Let's get into coding. Let's do a quick poll to understand how many of you already know a bunch of these things. It will still be slow for the next half an hour before we take a break, because we'll just write some basic programs. If you want to run ahead of the class, feel free to try to write these basic programs on your side. But I'm going to first do a poll to understand if we understand everything until now. Great. Cool. Love that. And then secondly, I'll do another poll just to understand. Do you guys already know these things like variables, arrays, for loops, while loops, if else statements in JavaScript? Do we already know this? Yes or no? Great. So 75% know this, 25% don't, which means we will basically do all of this from scratch slowly. The people who do know this, feel free to take a breather for the next 30 minutes. I think it'll take for us to cover this. And if you want, you can do these sort of assignments, problems yourself locally. That way, you don't feel like you're getting bored. Okay. Let's start with some basic syntax of JavaScript. Let's try to understand how you write code in JavaScript. What are the constructs you need to know of if you want to start to write programs in it. The first construct you need to know about is this thing called variables. This is across languages true. It's not just a JavaScript concept. And if I go back a few slides, as you can see here, I did a int number equal to 5. I did a let number equal to 5 here. These are what are called variables. As the name suggests, it is a variable, which means its value can change throughout the program. In C++, its type cannot change, but its value can still change. I could have done number equal to 6, number equal to 7 here. In JavaScript, you can go haywire, do whatever you want. It can be a number here, it can be a string later on, it can change to something else. It's called a variable because its value is variable. There are 3 ways to define a variable in JavaScript. All right. Yeah. Let, var, and const. There are subtle differences between them. Var was the original way to define a variable. Let and const came later into the picture. And as the name suggests, const is a constant, which means you can only define it once. If you try to change its value, it will throw an error. Let is basically you can change its value. That's a high level difference. There are a bunch of other differences which we're not getting into. Let, const are usually better than var. Var was archaic for a few reasons. Does a few there are a few downsides to using it. Generally, in any good program, you will never see var now anymore. You will only see let and you will only see const. Let's try to write some code again. Everyone who has Node.js, please do it locally. Everyone who does not have Node.js, try to open Replit now. Hopefully, it just works for you now. Let me try that on my side as well. Nope. Yeah, you'll just have to follow along if you don't have Node.js. Unfortunately, luck is not on our side today and Replit is down. So everyone else, feel free to code along. The people for whom it's not working, you can do it after the class when Replit is up. Generally, try to install Node.js locally. Okay? I'm writing some code. Would urge you to write the same code. Where a equal to 1 console.log a. Save this and try to run it. And you should see 1 printed here. Going to give you guys 15 seconds. All right. Hopefully that's enough time. And by the end of it, when you run node file name, you see 1 printed on the screen. Now try to change this to 2 and save it and try to run it again. And as you might be able to guess, it will now print 2 on the screen. What am I doing here? I am defining variables. Let's try to replace where with let and see if it gives us the same output. And it does. Try to do it locally as well. Going to give you guys 15 seconds to catch up and reach this code base. All right. What have I done? I have defined what's called a variable at the top. I have changed the value of the variable and then printed it on the screen. Harkiyat, what is console? What is console.log? It is just a function that JavaScript gives you out of the box. Just how you are not asking Harkiyat what is let, just JavaScript syntax. Similarly, console.log is also a function that, it's just present there, and what it does is prints whatever you've written here onto the screen, and you just use it out of the box without worrying about how it does this. Cool. Under the hood, it does a bunch of file system things, like Linux things that actually prints this to std out, but don't worry about it. High level, this prints something to the screen. If I replace a with 2 here, it will just print 2 to the screen. If I replace this with 3 here, it will print 3 to the screen. Basically, you can write either a variable here, which is a, whose value is 2, or you can, put the direct value of the variable here. That will also print that value directly here. Cool. Last thing to try is change it from let to const. And now try to run it. And you will see it throws an error. Why? Because const, as the name suggests, is supposed to be a constant, which means you cannot change its value through the lifetime of the program. You can define it once, and whatever you have defined it with is what you will, the value of that variable will be throughout the program. Why was it introduced? It was introduced to, add some safety to your program. Say, JavaScript, let's add some safety. Okay, people, if they know upfront something's value is not going to be changed, they define it as a const, so that if in the future somewhere they're changing the value, JavaScript throws an error, and then they're able to figure out their problem upfront rather than it becoming a problem later on. If you don't understand this part, it's fine. At a high level, 3 things we've understood: where, let, and const. Let and const are what you will use in the real world. Let whenever you want to define a variable whose value is changing. Const whenever you want to define a variable whose values won't change. Cool. That's the first very simple thing. Second thing is data types, which is strings, numbers, and booleans. So basically, you can have 3 types of, you can have multiple types, actually there are more, but the 3 common ones are strings, numbers, and booleans. Let's define 3 variables in our code base. Let name equal to Harkirat. Let age equal to, not revealing that, so let's do 18. And let is married equal to false. Cool. I've defined 3 variables. I can also log them if I want to. For example, I can write something like, so I'm going to introduce something here, don't get overwhelmed. I'm writing this person's name is name and their age is age. You should also maybe replace this with a different variable name, because as you can see, it says name is depreciated. It's probably used by JavaScript somewhere. So replace the name of the variable to something like first name. Why did I do this? Because JavaScript was complete. I can't just have my variable name be let, right? Let is a reserved word in JavaScript. Similarly, I cannot have it as if. Similarly, using name as a variable name is depreciated, so I just replace it with first name. If I run it, I see this person's name is Harkirat and their age is 18. I can do more fancy things here, like printing this person is married or printing this person isn't married. But for now, this is a good start. Take 30 seconds, try to write this code locally and try to log this on the screen. If you look at the syntax, it's basically I've combined raw strings and variables together to create this final long string here that is getting printed. You can do that in JavaScript. I could have also, if this feels overwhelming, you can totally just do for now, this person's name is, and then do another console.log, first name, and so on and so forth. You can write 4 console.log statements. That works as well for now. This is just a more concise combined way of showing this on the screen. Cool. 15 more seconds and then we will proceed. Try this out. Very simple, very high level basic stuff. All right. Hopefully this is clear. Let's do a few more things and I'll do a poll, and if it's fast, I'm happy to, slow down again. If else statements. This is a present in every language, so not JavaScript specific. It lets you run certain parts of code bases based on some condition. What does that mean? Let's try to print. Give me a sort of an assignment thingy, which is print to the screen, Harkirat, whatever, first name is married or first name is not married, based on what this variable's value is. So you might ask, Harkirat, we already know it's false. So why do I can simply do like console.log, first name is not married, because I can just see that is married is false. So I can just print this on the screen, assignment done. The answer is no. You have to use this variable, and based on the value of this variable, if I change just this variable, the output should change. You shouldn't have to change any code that you've written after this point. If this variable changes, your output of the program should change from first name is not married to first name is married. Cool. How do you do this is the question. So for that, you use if else statements. Let me write down both of these statements for now. Okay. First name is not married. First name is married. Let me run this program. What does it say? Harkirat is not married. Harkirat is married. Now what do I want? I want either this runs or this runs based on this condition. This is where if else statements come into the picture. What they say is, okay, if you want to run a certain section of the code base under some conditions, you use an if statement. So now you have to learn some more syntax with me, which is going to be if is married, curly braces, and then write all the logic that you want to run. Whenever this variable is true, you can also write if is married equal to true. Then do this. And the other syntax you need to understand is else, which means if this condition is not true, then run this. Now try to look at this code base and see if this makes sense. Now I never have to touch this code. If I change the value of this variable to false, then this section runs. Well, I guess this needs to be opposite. So let me just clean that up. So that's the right code base. I change this value. Based on that, a specific sort of code section runs. This is what if else statements are used for. Harkirat, could I have done this? If is married is true, then run this. If is married equal to false, then run this. Yes, you could totally do this. This works as well. But if else also works. Like in this case works. If is married could be 3 values. It could either be true, false, or I don't know, Bhupendra Jogi, or whatever, monkey. Then in that case you would have 3 different if else statements. So if it'll either go here or to the other section, then you can use if else. If you have some other fancy logic, then you can have multiple if statements one after the other. Cool. Is this clear? Is this simple? I'm assuming it is, but let's only the people who are beginners answer this one. Is this part clear? Not bad. So 94% is great. So I will proceed. But the people who are still finding this overwhelming, it's might be good to go through some basic JavaScript syntax video, or general basic programming language video that helps you understand if else statements. It's not too difficult, but if this is the first time you're doing it, it will feel difficult. And for that reason, I would urge you, after the class, either come back here, try to solve a few problems yourself, or go to a video which teaches this from more fundamentals. What are if statements? What are else statements? I will proceed here, but again, after the class, happy to stay back and answer these questions. It will get slightly harder from here. Try to bear through the rest of it. Loops, last thing we need to understand here, and then we're going to solve these problems. Loops are the last thing. What are loops? Let me start with the problem only. Let's solve this with a problem. What if I ask you to write a program that counts from 0 to 1000 and prints it? Okay, you have to write a program that counts all the values from 0 to 100 or 1000 and prints them to the screen. Ugly way of doing it. Let answer equal to 0, answer equal to answer plus 1, plus 2, plus 3, plus 4, plus 5, plus 6, and I can keep going. This is one way of doing it. If I write everything until 100 here and then do a console.log answer, then what do I see on the screen? I see 21 is printed. I hope these 3 lines of code are clear. How can you count from 1 to 6, let's say? You can also simply do this. Let me just make it even simpler. This is one way of counting from 1 to 6. Simple. 1 plus 2 plus 3 plus 4. JavaScript lets you do it. Most languages let you do it. You can do the same thing in C++ as well. What is the problem? The problem is, what if this number becomes 100, or if this number becomes 1000, or this number becomes 10,000? Will you keep adding numbers here? Probably not the right way to do it. So what is the right way to run some logic again and again and again and again multiple times? Let me break this solution into another solution. Let answer equal to 0, answer equal to answer plus 1, answer equal to answer plus 2, answer equal to answer plus 3, answer equal to answer plus 4, so on and so forth. I can also write code like this. If I keep going and adding more and more lines, by the end of it, I can print answer, and that will have the sum of everything from 1 to 4. I'm just adding them, all these variables one by one. What is the problem again? Problem remains the same. If the number becomes 1000, I have to add 1000 lines of code. That is not great. For this reason, most programming languages have this concept of loops, which basically means you can what's called iterate over a certain code segment again and again. If you look at it, all of these look the same. There is a subtle difference at the end, but they're doing the same logic in the end. They're taking the answer variable and adding something to it. Here the value of answer variable will become 1. After this line runs, the value will become 3. After this line runs, value will become 6, and then here it will become 10. Why is this? Because here 0 plus 1 will be equal to 1. Here value of answer will already be 1. So 1 plus 2 will become 3, and it will keep on going. Why is this bad? This is bad because you don't want to keep adding. For that, you introduce loops. So let's now introduce a new syntax. So few bad syntaxes we'll learn today. Let, where, const, if, else, and the last one I'm introducing is called loops. So for loop, these are things you will have to sort of memorize only to get by, and this should be muscle memory eventually if you're doing coding in any language. Writing some syntax and then I will explain it. For let I equal to 0, I less than 100, I plus plus, bracket open, bracket close, and inside this I'm going to copy one of these, and I'm going to change this plus 1 with plus I. Cool. All of these lines of code that were plus 1, plus 2, plus 3, plus 4, plus 5, plus 6 until plus 100 can actually be written in just 3 lines of code by telling the compiler, okay bro, just run this specific code 100 times. When you write this, what the compiler will do is, or when the code is running, what will happen is control will reach here, ki haan, let answer equal to 0. It'll reach this line, nothing will happen. It'll reach here. Here, when the control reaches, what do I mean by control reaches? Means when the code is running line by line by line by line, it'll reach here and it'll be like, oh, for loop. Okay, I'm going to start a new variable called I from 0. And until i's value is less than equal to 100, I will run this logic. So from I will just initialize I equal to 0. Then until this condition is true, I will keep running this logic. But every time I run this logic, I will increment I by 1. I could also replace this with I equal to I plus 1. What will this do? This, let's replace this. This and this are the same. 0, 1, 2, 3, 4. These 4 lines of code is the same as writing these 3 lines of code. If I make this 10, these 3 lines of code are still the same as, writing these 10 lines of code. This becomes 5, this becomes 6, so on and so forth. So rather just write this, because you can simply loop over a certain logic again and again and be like, bro, this value please pick from the I variable. And in every iteration, what is an iteration? Which means, every time this loop runs, you're going to add something to it. That is what this logic does. This logic and this logic are the same. Why is this cool? Because I can simply replace this I less than equal to by 100. And then by the end of it, if I print answer, I will get the sum from 1 or 0 to 100 in just 3 lines of code versus, the ugly way that I was trying. So if I run this, I see 50-50 on the screen, which if you have gone through ITJ, the sum of 1 to 100 by memory, it is 50-50. And the good thing is I can just make it 1000 now. And what I see on the screen is the sum from 1 to 1000. Going to do a poll and then proceed. Let's see. Is this bit clear? Do we understand the program that lets you calculate the sum from 1 to 1000 in this case? All right, great. That's perfect. So let's proceed. These are 3 programs I would urge you to write, but if this is clear, you can easily write it. Yeah, I think this is decent. Let's proceed. Complex primitives. So we are going to now understand something called arrays and objects, and then we're basically sorted. No, we have to understand functions as well, and then we're pretty much sorted on the syntax of JavaScript. We have done with the foundations that are simpler. The harder foundations are coming later on, which are this part right here, asynchronous programming. All right. Arrays and objects. Let's start by coding only. It seems like you guys are understanding this well. So write a program that prints all even numbers in an array. What is an array, Harkirat? Great question, sir. Usually in the real world, you have like databases of people, right? There are a million billion users on Facebook. So on Facebook, do you think whenever there is a program to, let's say, calculate all the people who have their age as 20, do you think they do something like this? Let person 1 equal to Harkirat. Let age 1 equal to 20. Let person 2 equal to Raman, age 2 equal to 23. And then, maybe even gender 1. Male. And then this is just too tedious to do it for 1,000 people, 1,000,000 people. So what is the right way to aggregate data is the question, and the answer in most languages is this thing called arrays. Let's convert these 2 variables, or let me just remove everything. Let's just think of people for now, like the first names. This is one way to describe 3 people with their first names. The other way is this. This and this can equally suffice when it comes to, doing something with the people database that you have. For example, I might ask you print every person's name on, in the Facebook database. So you could also do this console.log person 1, person 2, person 3, or you could do this print person array of 0, which means the 0th value here. Indexing in programming generally happens from the 0th index, which means this is the 0th index, this is the first index, this is the second index, and then you can do the same thing for 1 and 2. So this is how you create arrays. Why do you need arrays, Akira? For 1,000 reasons, we will come to it. But I have been able to create a simple array. And let me create a different array called, ages. 21, 22, 23, 24, 25. Let's say this is the age of all the people in Facebook's database. And the question I asked was, what was the question? Write a program that prints all the even numbers in an array. So you have to write a program that is able to print all the even numbers here. What are the even numbers here? It's 22 and 24. Can you guess this a little bit? We did this in the last slide. The answer is a for loop. So for let I equal to 0. I less than, I'm going to introduce something new here. Ages.length, I plus plus. And then inside the for loop, I'm going to write an if statement. Again, might feel a little overwhelming if this is the first time you're doing this. If ages of I, I'm going to introduce another thing here called the modulo operator, which basically means the remainder of this value when divided by 0 What will be the remainder of 24 when divided by 0? Sorry, by divided by 2. It will be 0. What will be the remainder of 23 when divided by 2? It will be 1. It will basically be 1 for all the odd numbers. It will be 0 for all the even numbers. What is remainder? Basic maths, if you might have done, if you divide a number, whatever is left at the end is called the remainder. And modulo lets you get that. This operator lets you, given a number and the value on the right, it will give you the remainder when this thing is divided by this. And if that is 0, that means this is an even number, so you can just log it. Ages of I. So I've written a few things here. Try to read through it. At the top, I defined a simple array. I did a for loop to iterate over this ages array. I checked if ages I modulo 2 equal to 0, then print ages of I. What does this mean? Okay, bhai, how many times will this for loop run? It will run ages.length times. What is ages.length? Let me store it in a variable. Const number of people equal to ages.length. And I can just replace this ages.length here with number of people. And then this works as well. If I run this program, let's see the output and then we can go from there. It says 22 and 24. That means our program seems to be working correctly. If I add 26 here, I add 100 here. The logic still works. It is able to iterate over this array completely one by one. And then under a condition, print something on the screen. Cool. Hopefully this is clear. I'm going to write some more code after this and then happy to do a poll. Then we have functions and then after some solving, we will take a small break as well. Cool. Let me just finish objects really quickly. Write a program to print the biggest number in an array. This is pretty straightforward. Try to do this later on after the class. Take this like as an assignment. Third option, let's read. Write a program that prints all the male people's first name given a complex object. First, let's understand what's a complex object. Until now, I've introduced arrays to you, which was the first thing here. I have not yet introduced objects. So let me introduce the syntax of objects. Then we will understand what I mean when I say given a complex object. Feel free to take a screenshot of this and code this later on if you've not been able to catch up until this point. Might be good to code, but feel free to do it later in your time. Going to remove this code for now. I just a while back showed you this. Const person 1 equal to Harkirat. Const gender 1 equal to male. All right. This is one way of writing this. We just saw, a better way of writing this is what? It is arrays. So I can actually convert this to this. Const person array equal to Harkirat, Raman, and const gender array equal to male and male. This works. I have two different arrays. If in the future there is a third field called, age, then I will have a third ages array. What was the question? Given these two, print the name of all the male people. So let me add a third person here, call them Priya. And then let's say they are a female. Now, one way to solve this problem is, let me remove all of this. Okay, I add a for loop similarly. Let I equal to 0, I less than person arrays dot length, I plus plus. If genders array of I equal to male, then print person array of I. Read through this code. I'm going to run node main.js. It prints Harkirat Raman. It does not print Priya. Why? Look at the logic here. It iterates over, it says for I equal to 0, I less than 3 basically. Person arrays dot length is basically 3 only, right? I can also const number of users equal to this and then be like I less than number of users, I plus plus, and then run this logic. So 3 times if genders array of I equal to male, then log this. What will happen in the first iteration? It will check, is this value male? Answer is yes. It will print this. Condition is on genders array. What is being printed is the person's array. Cool. Hopefully that is clear. Last one optimization here on top to make this code slightly cleaner is where I'm going to introduce objects. Okay, bhai, rather than maintaining 3 different arrays, what if I said you can actually combine values in JavaScript using something called objects. So you can do something like this. Const user1 equal to name Harkirat or whatever, first name Harkirat, and gender male. Ignore everything else for now. Just focus on this much. I have added a new syntax here. This is the syntax of objects. What was the syntax of arrays? It was const value equal to 1 2 3. This is the syntax of arrays. This is the syntax of objects. As you can see, it also has multiple values, and this can also somehow aggregate values. It can have multiple values in the same variable. What is the way to access a variable here? It is value of 1, value of 0. Value of 0 will give you this value. Value of 1 will give you this value, so on and so forth. What is the way to access a key of this object? It is this users1 of first name. If I console.log this, I will see Harkirat printed on the screen. If I console.log users1 of gender, I will see male printed on the screen. So what does this tell you? This tells you, okay, objects are also a way to aggregate data together, similar to arrays. And where are we going to use this for our problem statement? Our problem statement was the array looks something like this, which is probably the best way to create an array. It is an array of objects. What had we done until now? We had done array of numbers 1 2 3. We had done array of strings also, whatever, users 2 equal to Harkirat, Raman, so on and so forth. I am introducing a third thing here. I'm saying const all users equal to array of object, which means every field of the array is an object in itself. The first object is going to be first name Harkirat, gender male. The second object is going to be first name whatever Raman, gender male, and then the third object is going to be first name Priya and gender female. Why is this better than the existing approach? This is better than the existing approach. By the way, you don't have to code this locally in case you are. This is better than the existing approach because now you have a single variable rather than having a genders array variable and a first name variable, array variable, so on and so forth. And the logic still remains the same. Logic is going to be, it will be slightly different of course. Okay, for let I equal to 0, I less than all users dot length I plus plus. If all users of I, now something new will come. All users of I will be what? It will be either this object or this object or this object. I want to check their gender, so I will do all users of I of gender. So this is sort of a slightly complex object here. Bear with me for a second and I'll show a simpler approach to solve it as well. But I can do this. If all users, if the ith user's gender is male, then print whatever. The ith user's first name. Else don't do anything. So this is the final logic that I have written. The most complex bit here is going to be this. Okay, what is happening here? All users of I of gender. Can I keep going further, Harkirat? Yes, you can. What if this guy had another field here called metadata, which was, I don't know, age 21, address, something. In that case, you could also, be like I of metadata, which in itself is an object. So of age, so on and so forth. This can become more and more nested based on how nested your object is. Initially, our object was singly nested. 1 2 3. You can simply be like array of I. Then it became slightly more concept. It became array of an object. So in this case, it became array of I of whatever gender. If you inside this add another array and then another object, this will start to become more and more complex to extract the final value that you want. So that is why the logic might feel a little weird. If this does feel weird, I'm going to change this a little bit. I'm going to over here write, never mind. This is actually good enough. Let's not go there. It might complicate things a little bit more. Is this part clear? Let me just show you the complete code base. Can you try to marinate this if you don't understand it at least, what this code base is trying to do? More specifically, what we have learned is what are objects, what are arrays, and you can also create arrays of objects. Arrays don't necessarily have to be of just, strings or numbers. Is this part clear? Can we proceed? Cool. It's cool. Okay, so I'm going to increase the pace a little bit now. These are programs for you to try out later after the class. Last thing I want to discuss are functions before we move to some advanced things. Functions are things that abstract out logic in your program. They take arguments as an input, they return values as an output. You can think of them as independent programs that are supposed to do something given an input. Functions can take other functions as input. This will confuse you. Okay. Too many things together. Let's begin very small. Let's understand the syntax of a function. Write a function that finds the sum of two numbers. That's the first problem we're trying to solve here. Let's see. Function find sum. Feel free to code it on your side. Feel free to don't as well. It's very simple syntax. Look at this code base. What have I done? I've said I am defining a function and calling it find sum. I can name it sum as well. I can name it whatever I want. This depends on the developer. I have named it sum, and it takes two what are called arguments. What are arguments? They are input to your program or to your function more specifically, and your function is supposed to do things with the input and return an output. That is the goal of a function. What is the goal of a function? Okay, it will take some inputs, do some logic on top of it, spit something out. It is sort of a black box for people to use. For example, you can think of ChatGPT effectively as a function. Okay, it takes a prompt as an input, which is a string, does some heavy machine learning on it inside this function, and then finally returns the final output. So anything that takes an input as a few arguments as input, does some magic on top, and then returns a value is called a function. It's supposed to sort of do something very domain specific, which in this case is finding the sum of two variables. So this is how I can define a function. How can I call it? Like this. So I can be like const value equal to sum of 1 and 2. And if I print value, can you guess what's the thing that gets printed on the screen? Hopefully that's straightforward. It'll be 3, because what will happen when this code base runs, the thread will start from the top. It will reach here. It will be like, this is a function. I don't have to run this body yet. I know this is a function. I will keep this in memory. Anyone who calls sum, I will run this logic whenever this gets called. So the control will reach here. Then it will skip directly to this line. On this line, it will be like, okay, sum is called. So the thread will reach here. Here nothing as much is happening. Let me also make this cleaner. Const sum value equal to a plus b. Return some value. So the control might reach here, you sum it up, and then you return this value. That gets stored in this variable, and then that gets printed. So how is the thread going? It will go to line 1, then it will go to line 7, then it will go to line 3, then it will go to line 4, then it will go to line 8. That is how the thread is running. It's just because the thread starts from top to bottom doesn't necessarily mean it will run this and this. This whole thing will run together. And what is this whole thing doing? This whole thing is saying, okay, bhai, put this in memory in JavaScript. JavaScript should know that there is a sum function. Don't run any of these things. Just skip to the thing after it. Only when sum gets called will the control actually reach here. So if I call sum twice, let's say once with these arguments, once with these arguments, control will start from 1, go to line 7, go here, return the value store here, then it will reach line 8, then it will go again here, return, and then finally get printed. That's how the control would go. Why are functions cool? Because as I said, they're sort of a black box. They're a reusable code that other people can simply call rather than writing this. It's if you've ever done lead code, the thing that you see there are functions generally. Functions are basically sort of scoped, limited logic that other people can use as a black box. That's the reason why functions are sort of used. Cool. Arguments can keep change. You can have 10 arguments, 20 arguments. Logic will of course depend on the function, but that's how you write the basic syntax of a function. Let's solve one more problem and then we'll probably take a break. Write another function that displays the result in a pretty format. Another function that okay, there's actually a lot to cover here. Let's take a pause because we want to understand callbacks a little bit here, which are slightly tricky. So pause time, actually take a break. This class is going to be 2.5 hours at the very least. Going to open chat. How are we doing? Do we understand at least this much? What are functions? Do you have any questions? Is the pace okay? Let me also do a poll. All right. Someone asked some questions. What is the difference between array.harkirat.name and harkirat of name? It's the same. You can always be like harkirat of name is the same as harkirat.name. The only thing to keep in mind is don't do harkirat of name without double quotes. Make sure you have double quotes here. This and this are the same. If you do this, then there is a problem. Then it will try to find a name variable and replace this name with that string. So if I do const name equal to harkirat1 and then do users of name, so this is not this and this are both different things. This is users of harkirat, this is users of name. That's the only difference. Cool. Is it passed by reference or value? Good question. Most probably it is passed by value. We can confirm, but 99% it is passed by value. It is 99. We can confirm. Let's see. All right, so no other high-level questions. Everything is good. Micro tasks in an event loop, async everyday promise. Yeah, that's coming towards the end of it. We have a few things to cover before we reach there. Starting slow here. Cool. Alrighty. So break time here. We'll start again at 8:25. As I said, the things that are left to cover from now on are one thing we learn here now will be passing two functions as arguments, so callbacks. Then from there, we'll understand the event loop, callback, queue, asynchronous programming, and callback hell. Since this is the break time, let me just give the bounty as well. So bounty time. So that there's someone. Should I do it now or should I? Let's do it now. Let's do a bounty. This is the bounty for today. Where is it? There we go. There is a code base right in front of you. Try to look at this code base. It says let sum equal to 0. Iterates over from sum equal to 0 to a very big number, does sum equal to sum plus I, and then console.logs sum. Okay. When I run this program locally, what should happen? Can you think of it? It basically takes a lot of time, which means it'll take 20 seconds, 30 seconds, something like that. And I said that JavaScript is single threaded. So when I can run this command on my Mac called htop, which gives me I have 10 cores. And this is my CPU usage on those 10 cores. Some of them it is 93%, some of them it is 58%, some of them it is 33%. These are how they're utilized. If I take this code base and I run it locally, one of these cores should ideally go to 100% because, as I said, JavaScript program can only run on a single core. And as you can see, this is a very fuming JavaScript code. It's literally running. It's a for loop that keeps summing over and over. The thread is never free. It's running, for a really long time, 20 seconds, 30 seconds. So ideally, one of these should go to 100% because it's completely being used. This for loop, when it runs, should take one of them to 100%. Ideally, not everything should be 100% because JavaScript is not single threaded. We have not multi-threaded. We're not doing any multi-thread programming here. But when I run this code locally, let's see. I would urge you to try this on your machine as well. So this is the code that I was just showing, iterate over everything, console.log sum. I'm going to run this locally. And you will see none of them are going to 100%. Why is that? Can you tell? Okay, that is the question. Don't throw random problems. Take your time and figure it out. It took me, this is a very first principles question. Even I don't know the answer if I'm being honest. It should ideally go to 100%. One of them should be just focusing on the node process because as you can see, it's still running. It's not, partially running. So what is the reason why I don't see 100% here? Any guesses? Overflow value too big, wrong. Stack overflow wrong. Syntax error wrong. Async nature of JavaScript wrong. Set timeout wrong. Slow wrong. Threads wrong. Oh, okay. Someone gave a big answer. Let's see. Context switching garbage collection is converted to string. That is wrong. Process. So this is the code again. If anyone wants to see. Scheduling CPU, context switching, maybe V8 engine, no. It is using a thread, no. Using libuv, no. Context switching, integer range, exceeded, default value, single threaded, processor. Try it out locally. Take your time. Try it out locally. See it on your machine. Do you see it running at 100% or not? Take your time. Figure out. Most of the answers I see here are incorrect. So take this code base, run it locally. Try to run, some thing that lets you monitor your cores, which in my case is htop that I'm running, and try to see if any one of these, reaches 100% capacity. Hyper-threading, pipelining, largest value. Priority of processors, context switching. Context switching sounds like a good one. It isn't the answer though. Limit reached heap, overflow management. I think most probably it won't be able to context switch out. I mean, maybe it would actually. It distributes is definitely the wrong answer because it does not distribute. It cannot distribute. It is single threaded in nature. It is running most probably on a single core. Try to run it locally. Try to see it. We have 2 more minutes before we will proceed. Any close answer also I will take. And answers could be anything. Literally, as I said, even I don't know the answer very well. I know I have a little hint now, but it will be a very weird answer. Think from first principles. And programming is weird. Programming is dumb. There can be dumb random issues. This might be one of those dumb random issues. So don't take random guesses. All of these guesses until now have been incorrect. Take a more try to make a better guess. Optimization, single core. Let's see. OS scrapping out memory murmur. Stack Overflow keeps refreshing. Stack keep refreshing and freeing memory. This is not about memory though. This is about the CPU usage. Single thread because it's a Mac. No, due to asynchronous nature of single thread. It's a very weird answer, guys. Come on, think the weirdest thing you can. Programming is dumb. As I said, programmers are dumb. It could be something weird. Because 1 core equal to 2 threads. No, that is incorrect. Did any one of you try this locally? Bake integer, event looping, goes into event queue. Definitely doesn't go into event queue. Context switching. Context switching sounds like the right one. That's what I thought as well. But that is not the case. Nope. Disk scheduling. No. Okay, I'm going to open it one last time. I'm telling you, this is a weird answer, random answer, and then it's 8:25 already, so we'll have to proceed. Seems like no one's winning a bounty today. Did you try it out locally, by the way? And again, I don't know the answer. Nobody. There's no logical error. There's no CPU error. There's no burn in program, code distributes, concurrency, RAM. I'm going to pause here. If you had given the answer, then ping Rookie. We'll look at the chats, and if that is the case, you will still win the bounty. This was a $75 bounty. And the answer is going to blow your mind. So this did work. And so we did the same experiment in the last cohort, and this did work correctly. And I did the same experiment in the last cohort. A single core was getting overloaded to 100%, and others won't. And then we did something similar in Golang, and we could see every core being overloaded. So it did work correctly over there. Today just randomly stopped working. I ChatGPT, I asked Google, could not find a good answer. 99% the issue is in the htop command. It's not basically tracking my cores correctly. If I run the top command, and if I run this node b.js, you will see node is taking 98.6, almost 100%. So most probably 99.6, 98.7. Most probably, I'm still, as I said, don't know the answer very well. 99% the answer was the htop command on my machine isn't working correctly, which is why we don't see the right thing. I know it's a weird answer, as I said. It's supposed to be a little weird. Do apologize if you. Okay, can you fix Mac? This is a little noisy. Can you fix Mac? It's a little noisy and grainy. All right, that's so. Can you guys just tell me if my Mac, my voice, is my voice fine? Yes or no? All right, cool. Thank you. Some people are saying mostly yes already. So I'm going to proceed. Cool. So yeah, basically it's just a dumb problem. Took me a while today because I wanted to share this in the class. This is a good way to understand, cores and how it's working. And it did work for me for a while, but the answer literally is, the htop command is most probably, flushing out for some reason. And as you can see, it's 19%. Node process is running on a CPU with like full capacity. If I close this, then, it'll go away. But htop was just glitching. All right, cool. Sorry, no one won a bounty today. But as I said, programming is weird. Took me a really long time to figure out this solution. Also, I was running it locally. That's why I could see it. So don't fret. There are more bounties to come. No more bounties in today's class though, unless we get stuck somewhere. So if you were here for there, this is your time to leave. Everyone else, hopefully you had a good break. Going to proceed now as we understand. Last thing in functions, which is functions can take other functions as an input. This will confuse you 100%. If this is you are a beginner, this will confuse you. I'm going to try my best to explain it to you. But if you don't understand it, it's fine. It will take some while and you can understand it eventually. We're understanding this thing called callbacks. Let's see. So here is a simple example of 3 functions that I have written. Function number 1, sum. It calculates the sum of 2 inputs. Fairly straightforward stuff here, hopefully. Display result. It prints, given an input, prints the result on the screen. Display result passive. Prints the same result in passive format. Active, passive, English. I'm not even sure what is right, but as you can see, here it says result of sum is this. Here it says sum's result is this. The initial part is a little different. The question I have for you is, you are only allowed to call one function after this, which means you can either call sum or call display result or call this. How will you display result of a sum? You can only call a single function here. How will you sort of first call sum and then call display result in sort of a single function call? That is the question I have for you. How can you change this code base a little bit? Okay? There is a gist which has this code base. So let me just paste that in chat. Feel free to open this gist on your side. When you do, you will see this code. Feel free to copy this code and bring it over to your VS Code. Once you do, it should look something like this. This Codium thing is very irritating. Feel free to ignore this Codium AI thingy. I'll get rid of it the next time. So as I said, 3 functions. You can call only one function here, and you need to print the result of 2 numbers. So what is the first approach? Const answer equal to sum of 1, 2. And then once you've done this, the second thing you can do is display result of answer. You can do this, but as the question here says, you can only call a single function. So you need to change something here so that, this function can sort of internally somehow call display result. So you might say, Harkirat, I will do this. I will change sum to be. So what is the first approach? This is the first approach. Hopefully this is clear. I first do the sum of 2 numbers, put it in an answer variable. Then I call display result of answer. And that way this thing gets printed. Let me quickly run this locally and hopefully we see the right thing, which is result of the sum is 3, which is result of the sum is 3. So it works. The problem is 2 function calls. How can we do it in a single function call? You might say, Kirat, let it not return anything. I'm going to simply call display result of result here. And then the end user only has to do a single function call. And in a single function call, I got the result. I printed it on the screen. So we are good. I will say you are right. There is still one small problem here, which is what if I now tell you, nahi bro, you have to display result in the passive format. No longer you want to have to display it in this format. How will you do it then? You will say, Kirat, I will just replace this thing here. Now I will say, you have to give me a code where you are not allowed to change any of this. You can change things here. You cannot change any things here. Can you update this code base somehow so that I only do a single function call and you are able to either display this or display this? You can change logic here. You cannot change any logic here once you're done with your coding. So let me revert back to the original code, which looked something like this. And hopefully it's clear what I'm asking here to do. Okay, in a single function call, do this. So I'm going to share the solution. If you want to think over it, there's no real easy way to think over it. If I'm being honest, it's very hard to figure this out from first principles. So I'm going to share the solution. And hopefully this clears out what are callbacks. So what we need to do is we need to either basically call this function here or call this function here. So what if I pass in a third argument to this function, fn to call, which means function to call, which means other than numbers, strings, I can also send in a function here, which is I will send display result. What have I done? I've said 1, the value goes here. 2, the value goes here. Display result, a function goes as an argument to a function. Why is this cool? Because I can simply be like, remove the last line. I'm going to do function to call of result. Why is this cool? Because now I can simply change what function should get called, pass it as an argument, and that is what will get called here. That way we're able to solve what it was asking us to solve, which was you are only allowed to do a single function call after this. I have only done a single function call after this. I have deferred the second function call here, but the only way I could do that was by, passing a function as an argument. These are what are called callbacks. This is the confusing concept I wanted to share. Let's run this locally and see if it works. What did I say? Result of the sum is 3, which means this function somehow called display result. You might say, Harkirat, now I can totally see this function calling this function. But here too it says fn to call. What is this fn to call? This is an argument similar to num1 and num2, right? Num1, num2 are different from 1 and 2. The value gets passed in there. Similarly, display result is a function that gets passed here. That is the value that's stored in this variable, and you can just call this function. Cool. Take a breather. Let me do a poll and see if this is clear. This is probably the first jarring concept, after which we'll, as we get into promises and other things, it will get more jarring. But is this part clear at least? Okay, cool. That's fine. Decent bunch of knobs. So we're going to discuss this one more time, a few more times until we reach at least 90%. So let's revert back to, let's make this even smaller. Forget everything we have discussed until now. I'm going to write some code here. Function calculate arithmetic. Cool. A, B type. If type equal to sum, return A plus B. If type equal to minus, return A minus B. All right. Hopefully this is clear. I can do a calculate arithmetic const value equal to arithmetic of sum, and then do a console.log value, and that should, hopefully you guys understand, the control should reach here, here, and then here, and then what will get printed here would be 1 plus 2 equal to 3, and I can also pass in minus here. This is cool. This works. This is one way of solving this problem. Okay. What if I say you cannot write any such logic here? All this logic of sum, minus should be written in different functions. You'll be like, okay, I can define a function here, call it sum, which will return A plus B, and then subtract, which will return A minus B. I have just defined two functions here, and I will replace this with const value equal to sum of A comma B, return value, const value equal to sub of A comma B, return value. Try to marinate this code base. We have not done anything too different from what was done like a few minutes ago, which was I was subtracting and adding here directly. Now I'm just deferring that to other function calls. Is this code base clear to us? No callback yet. It's a simple function that takes two inputs and a third input, which is the type. Okay, this function should calculate arithmetic based on add or subtract based on the inputs that are provided to it. Time to do a quick poll here. There we go. Is this function clear? That has no callbacks yet. Alrighty, this is cool. From here, what I say now is, okay, you're not allowed to do any of these if-else checks inside. Just I see that for whatever reason, you're not allowed to do these if-else checks inside. Change this function somehow so that, you don't explicitly call sum or sub inside. I'm trying my best to fabricate a use case here. I'm not succeeding very well, but let me, change this whole thing a little bit. Okay, this is how we were doing things until now. Two functions defined, and then const this is equal to calculate arithmetic, two variables and minus. What I'm doing now is, okay, bro, third variable is going to be a function itself, which means rather than it being type, it will be a function. I'm going to replace this variable with arithmetic final function, something like that. And rather than passing minus here, I will pass either this variable or this variable. Harkirat, are you saying you are passing literally a function as an argument? Yes. I'm literally saying ये जो body है ना, take this body, pass it as an argument. Basically, when I do this, forget everything. This that I've done here, let me just do some things here. Answer equal to arithmetic. Let me just bear with me for a second. All the code that I've written here, ignore this for now. Just focus on this function and the fact that I called calculate arithmetic with 1, 2 and sum. When I pass this sum here, right, it is the same as, ignore the third argument, same as me doing const this equal to whatever this sum function was, you know, basically replacing arithmetic final function with like a function, basically defining a function inside a function, which is also something you can do. But effectively, I'm passing it as an argument, which means the third argument here effectively becomes the sum function only, which means similar to me defining this very function inside. And then when I call it, it's basically, you know, me again calling this thing, which will, you know, run the right logic. So effectively, I'm just passing the function, the whole thing, literally the function signature. Okay, bhai, this thing can be called inside with inputs from this calculate arithmetic function. This function can internally call this function. That is what is called a call back. As the name suggests, a function is going to call back a different function. Calculate arithmetic is a function. When I'm calling this function, inside this function, I'm calling back the sum function, which is what sort of this logic does. So just this bit, try to marinate a little bit. What is the value of this? It is a number. What is the value of this? It is a number. What is the value of this? It is a function. It is the same as whatever is being passed inside. The same body you can just define here. Okay, haan bhai, this becomes this inside. And that way, when I call this, it runs this body, and that specific sort of code segment runs. So just passing this as a signature. Is this, let me just run this locally as well. This is supposed to be jarring, so very hard to get it the first time. But when I do run this, as you can see, it returns 3, which means 1 and 2 were passed in. This was 1, this was 2. This was this thing. Answer equal to arithmetic final function. This thing calls this, which is why, and it passes in what? The A and B that it got, it just forwards it to them. It does a call back. It tries to call back a different function, gets the value and returns it. That's what sort of is at a high level, passing functions inside other functions is what is called a callback. Supposed to be jarring. You don't get it, it is fine. But is it high level, little bit clear? Okay, not great. It's at 87%, which is not, it's actually at 85%, which is not great. So we're going to continue along. Let's break this down into a smaller, let's see if we have another problem that we can solve. Let's switch the problem so that, you know, we start afresh from something new. One more time, I want to explain this, and then we will, irrespective of what the result is, proceed. Okay, let's do this. Let me introduce a new function to you guys called set timeout. Some of you might have heard of it, some of you might not. The set timeout is a function that is written by someone else, like a global function that JavaScript provides you. It takes some inputs. It takes some logic as an input. First argument, we will get to what the first argument is. Second argument is basically the number of seconds is basically a number which represents the number of seconds you need to wait before the first argument runs. So basically, let me define a function here called greet, which basically does a console.log hello world. And I'm going to say call set timeout is what? It is a function that someone has written. So basically set timeout, whoever is written looks something like this. Set timeout a comma b accepts 2 arguments, and then they write some logic of theirs inside. We don't care about what this logic is. This function is written by some really smart people. Ignore who. I am calling this function with 2 arguments. Second argument is after how many seconds, which in currently how many milliseconds basically, which basically in this case is going to be 1 second or 1000 milliseconds. After how much time should this function get called? That is what set timeout does. Okay, but yeah, after 1 second, call this. If I run this, you will see it'll wait a 1 second and then hello world gets printed. If I increase this to 3, then you will see 1, 2, 3. After 3 seconds is when hello world gets printed. So I just called a function, gave it 2 arguments. The first argument here is a function itself. Set timeout, what is it supposed to do? It is supposed to call a function after a certain duration. What are the 2 arguments I gave it? A function and this thing. Even this is a callback. Me passing a function as an argument is a callback. I can define a different function here called, whatever, greet alien, hello alien. And if I replace this greet function with greet alien function, then after 3 seconds, what will run? After 1, 2, 3 seconds, this function will run, hello alien gets printed. This never gets printed. Is this clear? How is set timeout working? How it works internally is something we don't care about. That is something JavaScript people have written. But do we understand at a high level how set timeout is working here? All right, great. So as you can see, I passed a function as an argument. That is exactly the same thing that I did a few minutes ago, right? Only over there, I owned the set timeout logic as well. I sort of owned the function, this function, and I was taking something function to execute as an argument, and then actually, calling that, which felt jarring. How is, I guess I understand. You understand you can pass a function as an argument. What you weren't able to understand was how are you calling it. If you don't care about this logic inside, then it's fine and it works. I can also introduce a new one here called set interval, which again does the same thing. It just calls it at an interval, which, if I run this, it will basically print greet alien every 1 second. It's like running at an interval. So the thing that's jarring is actually, the body of the function. But if you really look at it, whoever has written this set interval function or whoever has written the set timeout functions are taking 2 arguments of function. You can call this whatever you want. You can call this ABC, you can call it A, whatever, and a duration. And whoever has written this set interval function or set timeout function is also eventually calling A, right? Is eventually calling A. Now A, the name has changed. You passed in greet alien. The value became A here. But that is true for other arguments as well, right? If you pass ASD here, if the value here is duration, that is what you will get as the value here, right? Similarly, if you pass a function, the name of the function changed, but the body is still the same. If I call that, set interval will call that, right? That is how this is getting logged every 1 second. So that is almost similar to what we did in our slides, right? Or in our code, right? Which was, let me revert back to our code now. If set interval, set timeout is clear, then hopefully that our function will also be clear. But yeah, as I said, callbacks are supposed to be jarring. So there you go. This was our function. Just like set timeout, I called set timeout. I passed in 2 variables. First was a function and second was 1000. Similarly, I called calculate arithmetic. I passed 2 arguments and then I send a function. The body might feel jarring. What is it happening? How is this getting called? But I hope you get it now. Okay, this function reaches here and then you just call it, store it in the answer value and return it. That is how a callback is getting called. Similar to set timeout will also be calling, if I change the set timeout signature to look something like this, duration, so it will internally be doing something like sleep for whatever. Just assume this is like some syntax, sleep for duration, and then eventually be calling this only, right? Set timeout is also doing this only. When you call this, it waits for this duration time and then calls it. Your calculate arithmetic just forwards the inputs that you sent, A and B, to the third function that you sent, which in this case is sum. Let me leave you guys with this code base now. Now is this thing clear? Now is this thing clear? If I replace sum with subtract another function, then this guy will call subtract and return that guy's value. And that is how your function is calling back a different function. Beautiful. All right. So we will proceed now. One difficult concept out of the way, one first starting concept out of the way. This is all we have done until now. Why languages? Scripted versus compiled languages, or interpreted versus compiled languages more specifically. Why JavaScript is better than some languages in some use cases, more specifically just browsers and web development. Strict versus dynamically typed languages. Single-threaded nature of JavaScript, some primitives in JavaScript, numbers, booleans, things like these. Complex primitives in JavaScript, arrays and objects. Functions, more specifically, the most difficult bit in functions being functions passing into other functions as callbacks. And lastly, some practice problem solving, which we didn't get the time to. You will have assignment at the end to code a bunch of things, but this is what we have done. What is left? What is left is the thing that so the last code we literally started here. So these are things that we covered in this one. Last code started here where we understood, callback functions, while loops, things like these, and callback hell and promises. So let me introduce this a little bit. Let me do an offline video after. And let's just take a 10-minute break first. We've covered a lot of things. Then let's do a poll. If you guys can still keep going, then we will keep going. If not, I will cover all of this in an offline video. Going to open chat. How are we doing? At least do the basics. I think we should take a pause and do some questions here. Is it the same as recursion? Is it the same? Oh, great question. You could say that, right? Recursion is the function calling itself. This is not calling itself. This function is calling sum. This function will either call sum or whatever, sub, based on what argument is being passed here. So it's not calling itself. So it's not exactly recursion. I tried to use this, but I received output result of, okay, let's see. I tried to use, so let me just paste the comment from this person, from Mihir here. I tried using, oh, great question, sir. Fucking beautiful. They said, I tried doing this, but it didn't work. What argument are you sending inside? You're saying, what was the display result function? Oh, no, wait. What was this code base? Let's see. Display result. There we go. You shouldn't receive undefined, sir. If this is the code base that you used, which let me just go back to the gist and copy it. And you called display result of sum of 1, 2. You shouldn't receive undefined. If I run it, I don't see undefined anywhere. I see result of numbers. So you should be fine. All right. Let's see if there are more questions. I ran bounty code on Ubuntu. So yeah, I ran the bounty code on Ubuntu and observed that CPU usage wasn't consistently 100% on a single core. Instead, was being switching across cores in different cores. Could the reason? Good question. So someone said I tried the same thing on Ubuntu, and they also saw, it was not 100% on a single core. It was actually, either context switching, and running on multiple cores. It seems because some cores were 50%, not a single core was 100%. That is a great question. Okay, does JavaScript, when you have a code like this, when you have a code like this, which will never make the thread free. It's infinitely running. It's never is the thread ever free. It's literally it'll keep going forever. Will Ubuntu, Mac, your OS ever context switch out of it, or will it hog a single vCPU? Is the question. My answer, the answer I think is it cannot hog a single vCPU, but at the same time I've seen it spike to 100%, so I could be wrong. This is a good question to ask ChatGPT later on. Does anyone know the answer? I'll open chat in a bit. All right, one last question before we I'll open it for the poll. The question is, what if the arguments for the callback function are different? Okay, there is a there is a sum function that has 2 arguments, and then there is, I don't know, a sub function that is, I don't know, or a mul function which is, multiply 3 numbers together, a, b, c, a into b into c. So their question is, if there are different arguments here for sum and mul, how will the callback function know? And the answer is, then this is not a use case for callback. Callback functions, you can't really change this, signature here somehow. You can do fancy things here if you want, but generally, if this is your use case, then you will not use callback functions here. You will call them independently. Cool. ठीक है भाई. It is 9 already. I can go further. I can show you the slides. What's left to cover? This is basically the slightly more jarring bits of synchronous and asynchronous programming. Happy to cover in an offline video, happy to cover next week in a live. Let's do a poll and then we'll go from there. Next week in a live might be a little too, we might spend too much time on this thing that's usually not really needed. So let me ask a new poll here. We have 3 options and you can decide what to do. Continue today, offline video, and then live next week. This is sort of an interesting concept to learn. So we should spend time on it. But yeah, let me know what you think, and we'll just choose whatever the winners say. All right, very close competition between continuing today and offline video, neck to neck. But offline video wins by a very small margin, if I'm being honest. I could have continued today, but let me just take AMAs, answer other questions, and then I'll just record right after this class, and that way, I can just, not right after the class, maybe take a break, and then I'll just post it max by tomorrow evening, the bits that are left. Opening chat for any questions, any jarring things, anything. I'll leave you guys with a few practice problems for today as well, so that you can, do something after the class, some coding yourself. Create a counter in JavaScript that counts down from 30 to 0. I've covered set interval, so this is actually fairly straightforward. Calculate the time it takes between set timeout calls and the inner function actually running. This is a good one. Okay, I sort of wrote some set timeout code right now, right? Somehow figure out, okay, let's say I call set timeout on a function here after 1 second, something like this. Somehow figure out, I don't know how, I'm not giving any hints here. Okay, after how much time does the control actually reach here? You said after 1 second it should reach here, but does it actually happen after 1 second? Does it happen after 1.1 seconds or 0.9 seconds? Somehow figure out when does the control reach here. If 1000 is given as the input, that's the second assignment. Create a terminal clock, which means in your terminal here, when you run the program, you should see, 1, 2, or, more specifically, RR, date, month, date, second. This is the current time. There, for next week, there are assignments, and they have tests with them. So I will create a video on how to set up Node.js locally a little bit and how to run tests locally. So try to, code it locally on your machine and run tests to make sure you're coding things right. Okay. Pause here. Opening chat if there are more questions, and then going to create an offline video for, asynchronous programming. Cool. Let's see. Screen is lagging, can't follow properly. I'll do okay, let's see. Let me create a poll just to make sure that's the case. Then we need to fix that. Were there operational issues today? Were you facing issues? Yes or no? When it comes to audio, video, things like these, were you facing issues? Writing tests are covered using most probably Jest and a super test or some framework like this. Oh wow, a lot of people had. Oh no, never mind. Oh, there were issues today. Did I ask the question incorrectly, or were there 50%? But that's not great. I feel like I asked the question incorrectly, so let me ask it one more time. Were there issues today? Yes or no? And if the answer is yes, means there were issues today. You saw video issues today. Okay, there were. All right. So let me take feedback after the class as to what those issues were, and then we'll try to fix those. All right. Thank you for that, Karthik. I totally would have missed it. Going to answer a few questions now. Let me just stop sharing so that maybe it helps with video. Do you suggest me to? Okay. Going to answer questions related to the cohort. Well, maybe let me do one more poll. Sorry, guys, just to understand the pace so that I can take things accordingly. How was the pace for today? Does what does single thread non-blocking mean in JS? Great question. Single thread means, okay, as I said a while back, okay, it can only run on thread is this operating system concept that some of you might have heard of. Okay, okay, why isn't the poll working? Sorry, just 1 second. Oh, oopsie daisy. Did I launch the wrong poll? Sorry, guys, just 1 second. Polls, back, paste. There you go. Zoom is glitching out really bad. I think it's just the number of people that are on the call. Same with Replit, I guess. All right, I'm going to answer the question, which was, what does single-threaded non-blocking means? Single-threaded means, okay, as I said, it can only run on a single core at the same time. That's high level what it means. What is a thread? Thread is an operating system concept, which means, the code that is running at a single time is called a thread. What does non-blocking mean? Non-blocking and asynchronous are very closely related. It basically means, okay, right, it was fast for 15%. Cool. Alrighty, thank you for the poll, guys. We can decrease the poll a little bit. I can also take an extra class for things to jarring things next week, so we can bring everyone up to pace. What I was saying was non-blocking basically means, if there are asynchronous calls that happen. For example, in JavaScript, if you make a database call ever, as I said, it is single threaded. So there's a single thread that's running. If you ever make a expensive call, expensive network call, expensive file system call, then it just defers that call and does not block the thread. That's what non-blocking means. But I'll cover all of this in the next part of the video that will come offline. Next week plan, please. So plan has changed a little bit. It'll now be all of these things that I said. A lot of assignments on practicing JavaScript, asynchronous JavaScript, which is a concept in itself, and a few more. What was the other thing? There's I think DOM. I discussed this in yesterday's class. Whatever the offline videos for next week were, which I think was like DOM and some basics like these. So some basics and some, this asynchronous programming, asynchronous JavaScript, which will also be covered in an offline fashion. But good question. Will this cover everything from cohort 1? Probably. Not everything, but the things that are good. Please explain the answer of the bounty. The answer of the bounty was most probably 99%. The htop command of mine is not showing these things correctly. The top, sorry about that. The top command is actually the right, it is showing the correct CPU usage here, which is why, that was the final issue. I googled this a lot, almost spent 15 minutes before the class doing it, and then eventually, just tried the other command and realized that's the issue. Could you upload the recording? Missed a lot during network issues. Yes, I will do it as soon as possible. It should probably be 2 to 3 hours. I'll try to do it ASAP though. Heavy tasks. Let me also open chat. What exactly was the issue? Can someone just explain in a very concise fashion? Was it video was chopping out? Was it audio was not good? Was it screen was slow? What exactly was the issue? Oh, oopsie, someone has explain that metadata thing one more time. Let me do that. It was stuck. Okay, audio was okay. Never mind. A few things. I will post the offline video soon. All right. Someone asked a question which I'm going to explain. I'm just going to take doubts now. So feel free to drop off. Officially, whatever end of class. We'll try to post video as soon as possible. But hopefully 2 hours at max. It should be there on the course dashboard. I don't think there's much if I'm being honest. Zoom is the best platform when it comes to video streaming, and if you're facing issues here, then we'll have to figure things out. Unacademy is the only other sort of platform that has live streaming as good as Zoom. So, and I don't want to move there. So we'll see. And it's very hard to build it in house in a week. So, there's another way actually. There is another way. So, next week we'll have 2 links. We'll have Zoom and we'll have an alternate link. So you can always also go there, and that'll work out. All right. Cool. Someone asked a good question, so I'm going to just answer beginner-friendly questions now. Someone asked, explain the metadata thing again, which I'm going to. The metadata thing is basically objects can be very complex. For example, let users equal to name, Harkirat, address, street, or whatever, house number 22, city, Mohali, country, India, so on and so forth. So this object may be very complex. And if you want to access my house number, you will basically do users of address of house number. So it gets more and more complex. You can also do let address details equal to users of this, and then do address details of house number. This also works. Or you can simply be like, hey bro, this of house number. Cool. That was the high level. Any more beginner friendly questions, so that at least this part is clear? So I'm just going to open it for doubts related to the things I've discussed until now. Anything difficult, jarring? Slides ka link is right here. I'm not sharing screen, right? Rookie has probably posted it in Discord somewhere, but let me also post it in announcements, so you can just find it there. Sorry about that. Is it true that 79% of the websites are built on PHP? That is probably true, and that's half of the reason that there might be, because most of the website, like 30% of the internet is WordPress or something like that, and WordPress is written on PHP. All right, I posted it on announcements, so you can look at the slides there. Audio was slow. Does that mean it was lagging? But okay, we'll figure it out. I know another way to stream. There might be high latency there, but it'll work. It could be handling other tasks, just entering users input, network requests. I think you mean JavaScript, the bounty thing. I don't have a clear answer to this, if I'm being honest. I don't know, but yeah, as I said, it's confusing. There's a video we did in the last code where it was literally at 100% and stop was working, and today it stopped working. So even I don't know what the best answer there is. Why is this code not working? Let's see. Set timeouts. There you go. Great question, sir. Why is this code not working? Because what are you sending to set timeout? You are sending this to set timeout. You are saying set timeout 30 after 1 second. Set timeout is like, this is not a function. What is sum of whatever 10, 20? It is 30. You're passing in 30 as an argument. What you need to do is something like function calculate sum, which will calculate sum from 10 to 20 and return this, and then put calculate sum here. Never call when you're sending the first argument. If you call, you are passing in literally the actual value which you were doing, which is like this. You are actually passing in 20 here, and that's the issue. The first argument is not supposed to be a number. It's supposed to be a function. All right. In callbacks, the function were, 1 second. Hello. Fucking hey. Sorry about that. Yes. Sorry about that. This is what I was saying. You are doing this. Thank God my phone was on. My phone was about to be dead. All right. You were doing this. You were sending 30 as the first argument, which will not work. What will work is something like this. Okay, you create a new function, call it calculate sum, which returns the sum, whatever, which returns 30 or the actual value. And the first argument here is calculate sum. You don't call it. As soon as you call it, you are not passing in function anymore. You are passing in the value that the function returns, which is actually 30. So if you pass 30 here, set timeout will be like, the first argument isn't a function. So always never call the thing that you're sending, just send the name of the variable, the name of the function. That's what the issue was. Alrighty. Chat again. I need to log in every time I visit the site. Can you fix it? Can you walk us through this feature? You shouldn't on app.100xapps.com. It has a very sticky login session. You probably need to do it on the other website, but we're going to move everything to app.100xapps.com. So hopefully over there, it should have a very sticky session, I feel. If not, then yeah, let me know again. What happens if we pass parameters with different order in a function in a callback? Next weekend will probably be Node.js if I'm able to cover everything in an offline video. We'll start Node.js a little bit back in HTTP, WebSockets, things like these. What happens if I pass different parameters in a parameter in different order in a callback? What if I pass? Could you elaborate on your question, Ashish? The question that you've posted is this, which what happens if pass the parameter in different order in a callback. So if there is a function, do something which takes 3 arguments a, b, and a function, and you're saying rather than calling function of a comma b, you call function of b comma a, then your function logic, whatever the logic inside it is, will do random things. It expects us whatever variable 1, variable 2. So if you give it the wrong arguments, flipped arguments, it will hallucinate and give you the wrong value, if that's your question. All right. Oh, get it. Just ignore the extra undefined. I get what you're saying now, Ritik. So you're saying this is your code base, and when you run this along with oh, you do see undefined. Great. Who will tell me and take a beautiful bounty as to why is undefined printed here along with this? $25, first person to post. Opening again. No return value. That is correct. Karthike most probably wins this. How did you figure that out without even looking at it? But good. Yeah, you're not returning function to pass here. That's the issue. And Karthike got it right. Let me see if someone else did. All right, cool. Run this again. Oh, why is it still failing? Wait, hold on. Function to pass of this. What is being called? Sum of 1, 5 display result, which is this. Oh, I still see this. Why is that? Oh, because fucking A, of course. Karthik was also sort of right. But the other thing is, sir, you are printing sum of this thing. And what is sum of this thing? It returns whatever this guy returns. And what does this guy return? It doesn't return anything. What are you saying? You're saying console.log sum of this. This returns nothing. You simply have to do this, and it will give you your result is this, because you said you're doing this const value. I hope you get it, but like const value equal to this, and then you're doing a console.log val. So you are doing this, and what does this return? It returns nothing, because if you go to sum, it returns this, and neither of these functions are returning anything. If they return something, if they would have returned whatever the string, then what you were doing was correct, but they're not returning anything, which is why const value equal to sum, and when you log it, it's not working. Someone else said void as well, which I guess is also the right answer. So Sambhav Khanna, you also pin a bounty. So 2 people pin bounty. All right. Opening chat again. Any more questions related to the class? And then feel free to like ping TAs for like questions like these. TAs are also going to get joined like today. So you can just ping them for these questions. In function callbacks, will the third parameter, which is the function, can be work as global variable? No, it cannot work as global variable. If you have a function which has 3 arguments, where the third argument is a function, if you have a global whatever function, let's call it do something, and a function sum, this is already sort of a global function. It's sort of defined here. So if you pass this as a third argument, it will be available here. But if let's say sum was not a global function, then whatever you pass here remains in the scope of this and doesn't go out, if that was your question. Can we use backticks instead of double quotes? Sure, in some time. So slightly jarring syntax, but sure. Like for a beginner, but happy to do it in the next class. I explain in the next class. If possible, can you post assignments today only? On weekdays, it will be tough to work for work. Okay, sounds good. We'll try to post it as soon as possible. What is the type used if else while explaining callbacks? What is type used in if else while explaining callbacks? Oh, it was something else, right? It was feel free to go back to the lecture, but it's basically before I actually introduced callbacks, I said A, B, and third thing will be a type, which basically will be a string. And then based on the string, you will run, logic like this, so on and so forth. So I was like, forget callbacks for now. Think of it as a single function that does everything. And here the third variable can be a type, which can be a sum or whatever. All right. Seems like there's a lot of lag. Okay. Lot of offline videos coming for you guys in the coming week then. If live is going to be a problem, and then yeah, we'll see what we can do. Because Zoom is probably the best. If Zoom cannot handle like these many people, then it'll be a problem. Hopefully just an internet thing on my side. All right. Cool. One more question someone has, but again, feel free to ask these questions to, TAs. Seems like they're some basic things. All right. Whoa. Could you ask the question along with this, Dilip? Just ask it to the TS. All right. Going to take a breather here. Going to stop screen share as well. Thank you for joining. Apologies for Zoom. We'll try to fix like whatever we can there. I'll post a lot of offline videos which will cover the things that are left from today. Actionable items to do would be whoever the beginner people who are having these questions, ping TAs, they'll help you out. TAs will be added by tonight, 99%, hopefully. If not, then tomorrow, but 99% they'll get added today. Assignments are already created. I will then post a subset of assignments now because, we've not covered async programming. The assignments are, there needs to be a video recorded along with it that explains how to run it locally. So basically try to do it as soon as possible, but might take some time. And at a high level, actionable item for you to do might be at least understand everything I was covered today, try to do all the assignments, try to do the asynchronous programming video that I will cover in the upcoming video. At the very least, do all of these things. Then you're up to speed, and then the other offline videos feel free to, they'll be simple, so you can skip them, but don't miss the async programming offline video that will come. That will be sort of important. That's the high level of what you should do next week. Hopefully, next week is slightly better when it comes to Zoom issues and speed. From what I can tell, 15%, 10% are still thinking it's fast, especially when I went to the JavaScript primitives, because it's slightly simpler of a concept and available, which is why we sped up a little bit. But happy to take a simpler class on that, or defer that to a TA in the upcoming week if needed. All right, cool. I think that's it. Let me just take a few more questions. Yes, what you're saying, Sanjay. So Sanjay saying, okay, let's add DVR to the website, which means people can go back during a live. We can do that. The only problem there is, there'll be a delay of 15-ish seconds. Let me do a quick poll here. Are you okay with a delay of 15 seconds in the live? If you're allowed to, go back in a live video and, look at it even during a live class, go back, figure things out, and then come back to the live section. Are you okay with a 15-second live? Will you use that 15-second delay? It'll actually be much cheaper. Zoom is like much more expensive. Okay, so mostly no. 50-50-ish. I mean, either way, we'll have to create like an alternate link from next week onwards. So you can actually pick and choose. If you want to come to Zoom, you can. If you want to go to the website and, you can also watch it from there. The reason that is good is because, scrolling back, you can, revise some concepts and then speed it up and, go back to the live class. So I'll just have to build that in the next week. So, or create a bounty out of it. I don't know. We'll see. Please read offline videos for beginners. I will create a few offline videos for beginners. I think from what I can tell right now is, we need to, these things probably, the first part should probably have been covered as an offline video, and then promises should have been a live video. But we'll figure it out. All right. Yeah, I think I did. Oh, screen was not shared when I explained metadata. Shit. Sorry about that. Let's see. It was basically, okay, what if const user equal to name. Also, guys, feel free to drop off. Like, just going to chat a little bit, then call it here. Address, street, or whatever. House number, street 1. And now if I want to access this thing, I can either do user. So I can do either console.log user of address of house number. I can either do this, or I can do const address equal to user of address. Once I have this variable, I can do const house number equal to address of house number. So this and this are the same thing. We're just putting them one after the other. So this seems very long and ugly. This seems slightly cleaner. Okay, chalo, first I get this value in this object, this value, and then I just access the house number property there. So that's the metadata thing that you were asking about. Cool. Let's see more questions. The chat's closes pretty fast. How am I supposed to ask questions for bounty doubts? Bounty, great question. Doubts ka to you will have to ask a lot of doubts in Discord, I feel. And bounty, we'll have to figure something out. We'll have to probably create something in house because yes, it is very quick. The bounties are also very weird. So you can't really answer. A lot of people can't answer them, but I totally get. Bounties will be a problem. Few things I can think of is either bounties go in a live video or in an offline video. In an offline video, explain a feature. Whoever does this feature first gets it, and there's a submission form, so that way it's easy to track who was the first person who submitted it. Yeah, we'll figure it out. Is multi-threaded only for compiled languages? Is it not exactly compiled languages do multi-threading and interpreted languages don't? It is just by coincidence that Python and JavaScript are both interpreted and are both don't support threads, but I'm sure there are interpreted languages that are multi-threaded. There are compiled languages that are single-threaded. There is no problem in the video audio. You asked the wrong questions. Both. Is that so? That would be super weird. So I'm going to ask it one more time. I might have just asked the wrong question again. So let me just create a new poll here. I felt like I did that. Okay, so maybe wouldn't the voice just kill the thread if it's infinitely running? Not really. As you saw, it was just running, right? It's doing a computation. Unless, yeah, it'll just run. Let's see. Did you face issues in Zoom today? Yes, Zoom was shit. No, Zoom was great. Okay, I've kept it very explicit now, the poll. So let me know if which one of these two statements is true. So it was shit. Yeah, so there was an issue. All right, cool. Very surprising. Zoom is supposed to be the industry standard. Understood everything. How to keep concepts in mind without using them regularly, like the object concept. Solve a lot of problems from the assignments. I think there are like 10 to 20 problems for the assignments this week, so spend some time there. All right. We need more offline videos for beginners. Yeah, I feel the same. So let me create some. And yeah, I think so. From a high level, what I can understand is offline videos cover a bunch of basic things, and live videos for the advanced stuff. All right. Can you make a video on Linux on installation? I can, but it will be very different for every person. So yeah, that's the high level. I can, but like probably one I don't have a Windows machine. Two, even if I do, it does not mean it will be very easy for you because every machine is different. So yeah, where do I find recorded video? Is it available on app? It is available on the app. It's in a specific folder. So if this is the app that you're on, go to the cohort. Oh, sorry, wrong one. There's a folder there called course content app. Just go to that folder. You'll find the videos there. So basically 0 to 1 course content. And then, oh, there you go. Sorry about that. And here you'll find the orientation video, and then you can go from there. All right. Wow, very long question. Okay, Vaibhav has a question. Let me just copy it so everyone can see it. Function to function calls. You can think as if we are passing a third argument as a reference. When we say reference, it means implementation is the thing that he's passing down. And hence the name can be anything, and hence that kills what it's working. Behind the scenes, the code. Okay, feel free to read through this, take a screenshot. I think it's a better explanation of callback functions. Yeah, feel free to read through this. Going to put it on the side. Oh, screen is not shared again. You are not wrong, sir. There we go. So yeah, feel free to read through this. Someone I think has a good explanation of callbacks. The problem was video was lagging. Request, can you please your video off and only share screen so that it can reduce the network bandwidth? We can try that. I don't know if that will fix the issue, but we will try that. How to ask questions, small chat window time? Is it only copy paste? Good question. What you can do is, so what we will do is we'll ask the TAs to be responsive during live classes for 2 hours. That way, you can just ask in your Discord subgroup and TAs will be able to answer it. That's a better way to sort of, I think, go through this. Sometimes the screen was freezing and the audio was stuck for 5 to 10 seconds. Happened 3 4 times already. It was not terrible, though. We can work with it already. Cool. Cool. Someone also has a curious. All right. I'm just reading through questions, trying to find any question that can help everyone here. So, okay. At a high level, all the questions that you have related to, the doubts that you have, try to post them on Discord after the TAs have joined. They should join today, most probably. And any other questions, they'll answer your questions. Any other high level questions, I'll try to answer on Discord. Feel free to tag me for the next 1 hour. I'll try to be available, maybe 30 minutes. Tag me on Discord on any high level questions, on any technical questions that you have. Try to ask TAs. They'll get added hopefully in an hour or two. Same for the recording. And yeah, I think I have a few things we need to change generally, but thank you everyone for joining. Other than that, and I think we'll call it here. I'll see you guys in the offline videos. All right. Cool. Thank you. Also, if it's not working for you, if chat is too fast, the refunds are still open. Feel free to ask for them. If you feel chat is fast and it's not working out for you for whatever reason, you should ask for a refund if this feels like fast or whatever. Especially asking questions and things like these. So yeah, make an informed decision there. All right. Cool. Thank you, everyone. I'll see you guys next week.